Okay, today we are going to be doing solving systems of two equations and two unknowns algebraically using substitution or elimination. What I'm going to do is you have the notes filled in with the methods. So really what I'm going to do is do the example as you look at the steps. So substitution. The first step is solve one of the equations for one of the variables. Says, if possible, solve for the variable that has a coefficient of a positive 1, which would mean it has nothing in front of it. So if we look at this system, this equation would be easy to solve for x because nothing is in front of it. So I'm going to label it steps. Step number 1 would be get x on a side by itself. You can get x on a side by itself or y. Subtract 3y, x would equal 3 minus 3y. That's your step 1. Step 2 says write down the other equation. So the other equation that you did not use was 2x plus 5y equals negative 5. You're going to substitute. Now it all depends on what you solved for. Since we solved for x, we're substituting for x, which means this expression is going to go in for x. You will need to put parentheses around that quantity. So 2 times 3 minus 3y. It's taking the place of the x. You do not write the x. You write 3 minus 3y. Then write the rest, plus 5y equals negative 5. Now it says solve. So I'm going to solve this equation. Distribute 6 minus 6y plus 5y equals negative 5. Combine like terms on that side. So minus 6y plus 5y would be minus 1y equals negative 5. Subtract 6 because your job is to get y on a side by itself. Divide by negative 1. Y equals 11. So your answer is an ordered pair. What you've found so far is one part of the ordered pair. Since you found the y, it's going in the y spot of the coordinate. So now we're to step number 3. Step number 3 says take that answer, substitute it into your answer from step 1, which I put a box around. So step 1 was x equals 3 minus 3y. So if I write that down, I now know what y is. So x is going to equal 3 minus 3 times 11, which would be 3 minus 33, which would be negative 30. So now you have the second part of your ordered pair. Negative 30, 11 would be the point where those two lines intersect. You can check. Step number 4 does say check. If you press if you plugged in negative 30, 11, negative 30, 11, you should get a true statement in both those equations. Okay, so elimination or linear combinations. Step number 1 says line up the equations. Your x should be underneath your x, your y should be underneath your y's. Most times that's already done. So now it says step 2, multiply by the numbers to get opposites. So you look and you say, okay, I got 3 and 5. You could multiply by 5 to get 15, negative 3 to get negative 15. If you wanted to do your x's. If you wanted to do your y's, you have 3 and negative 9. So I could multiply just the top by 3 and keep this one the same. So I have 9 and negative 9. I'm going to do the y's. So you multiply the whole equation, both sides, by that number. So you'd have 3x, you'd have 9x plus 9y equals negative 45. And if you're going to multiply by 1, that's just going to stay the same. 5x minus 9y equals 3. Now, when you're done with step 2, you should have positive and negative the same number in one of the columns. You add 9x plus 5x is 14x. 9y and a minus 9y goes away because they're opposites, equals negative 42. Solve, divide by 14, you get negative 3. Again, that is one part of your ordered pair. This time it's the x spot because this is my x, this is my y. Now, step number 4 says take this answer that you got and go to any equation. You could go here, you could go here, you could go here, you could go there. So let's just say I went and put it into the original equation. I'd have 3 times negative 3 plus 3 times y equals negative 15. Solve. Negative 9 plus 3y equals negative 15. Add 9. You get 3y equals negative 6. Divide by 3. Y equals negative 2. So then that's your y. Again, you could go and check that. You should check that on a test and make sure 3, negative 2 works in both equations. So that's substitution and elimination. Now we go to special cases. So we have these two equations somewhere where different things can happen. So I have x minus 2y equals 4, 3x minus 6y equals 8. If I did this with substitution, get x on a side by itself, I would add 2y. 4 plus 2y. If I substitute that in for that x, I'd have 3 times 4 plus 2y minus 6y equals 8. Distribute 12 plus 6y minus 6y equals 8. And as you're solving that, these go away. So now I have 12 equals 8. You can't solve for y or x if you don't have an x or a y. So with this, notice that 12 does not equal 8. So if the variables cancel and each side is not equal, then there is no solution. Now, what is that called? If there's no solution, graphically that's parallel lines. It's an inconsistent system, which on your notes happens to be the second blank. So now we have this one. Let's say I did this one by elimination. So I multiplied this equation by 3. Top one stays the same. I multiplied by 1. Bottom one, negative 12x minus plus 3y equals 9. If I add that, that goes away, that goes away, that goes away. I got 0 equals 0. Now, I could get 5 equals 5, 6 equals 6, 80 equals 80. If you get a true statement, so variables canceled and you got the two sides equal, that is many solutions. What type of system is that? that would be with many solutions is a consistent and dependent system, which again is the same line graphically. Okay, so we should be good to solve some of these in class tomorrow. We'll see you tomorrow.